Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 424. Please turn to it, page 424, and today is our lesson number 14. Let's take a look at it. In number 14, we are given this ball here, and we are told that we can color it two different colors. Color 2, color 1, and color 1. It says if 5 different colors are available for the design, so we have 5 different colors that we can choose from. That's very important. Here is our color 1, here is our color 2. Let's see what they're asking. How many differently painted designs are possible? Well, there you go. How many different ways we can paint the ball? Very simple, very straightforward. Ask yourself, if there are 5 different colors that you have to choose from, how many different ways you can choose color number 1? Well, obviously 5 ways, because there are 5 colors. Once we have chosen one of the 5 colors as color 1, by the way, it doesn't matter whether you call these two color 1 and this one color 2, or whether you call it the other way around, it's not going to make any difference. There are 5 different ways. You can choose either this end or these two end, or the middle. But once you have chosen color number 1, whichever one that you're calling color 1, once you have chosen one color for that part, how many different ways you can choose a second color? Or obviously 4 ways. Because you wouldn't go around painting the so-called color 2 the same color, would you? Because then the whole thing is going to be same color. There will be no point in it. So there are 5 different ways you can choose color number 1. There are 4 different ways you can choose the second color. And therefore altogether there are 20 different ways you can paint your ball. That's all there is. That's all there is. You understand? The other way, the other form this question appears in the SAT, it has appeared in the past, is something like this. They tell you that on your bookshelf you have room to put 2 books. And you have 5 books to choose from. 5 books to choose from. If on my bookshelf I have room to put 2 of these 5 books, how many different ways can I arrange 2 books on the shelves out of the 5 books? Understanding the fact that you won't be able to, the 3 books will not go on the shelf, obviously. Well, there are 5 ways I can put a book in the first space, and there are 4 ways I can put a book in the second space, because I have 5 books to begin with. So once I have chosen one book to put in the first space, now I'm left with only 4 books. So for the second space I have 4 choices. That's all. Let's do the next one. Number 15. Number 15. Now listen, before I actually do number 15, I would like you to listen to me what I have to say here. I would like you to watch this video, and you will find it fruitful, I think. GRE Math, day 108. Now I realize that you are not here for the GRE. You're only in high school and you are about to take your SAT. But go ahead and watch the videos anyway. Trust me on that. You will find it most likely helpful. The question that appeared in the GRE and the question that we're about to do, number 15 that you see in front of you, are very, very similar. Having said that, let's do the question then. But after you finish watching this video, just type in this tag. That's all you have to do is type in GRE Math day 108, and in the title it will say quantitative comparison. Because I have another video with the same day number, day 108, which will say revised GRE. I'm not talking about the revised GRE. This is what you will see. Okay? And if you don't know what GRE is, don't worry about it. You can Google it and you can learn it on your own what that is. GRE is basically a higher level of SAT. You're taking the SAT right now to get in the college. Once you have gotten in the college and once you get your 4-year degree, if you decide that you want to go further in your studies, you want to get your master's degree, while you have got to take the bloody GRE, the bloody SAT. And that college level SAT is called the GRE, Graduate Record Exam. That's what that is. But the questions are very, very similar. Let's take a look at it. It says that if the length of a rectangle is increased by 30% and the width of the same rectangle is decreased by 30%, what is the effect on the area of the rectangle? So the easiest and the simplest way to do is to make up a rectangle. Don't try to do this problem theoretically. Don't try to do this problem algebraically. You could solve these questions algebraically. There are two ways of doing this one: the traditional way, the classical way, the orthodox way, the geeky way, the nerdy way, the algebraic way, the academic way, the way that will make your math teacher very proud of you. Let's not worry about our math teacher right now. Our job is to solve this question as efficiently as possible. Make up a rectangle. Make up a rectangle. And let's pretend it is 100 by 1000. 100 by 1000. Okay. What's going on? We are told that we are going to take our rectangle. This is our original rectangle. We're going to, which one are we increasing, which one are we decreasing? The length is to be increased by 30%. Alright, so if you increase the length by 30%, what is 30% of 1000? 30% of 100 is 30, 30% of 1000 is 300, 10% of 1000 is 100, because it's 1/10 of 1000. Therefore it goes up by 1300, not goes up by 1300 rather, it does not go up by 1300, it goes up to 1300, it goes up by 300. And the 100 here, the width, we are told we are supposed to decrease it by 30%. 30% of 100 is 70. You see how nice the numbers are? That's all there is. That's why you plug in. Whenever the question is dealing with the concept of percentages, good numbers to plug in are multiples of 100. That's all. So we're comparing. Here's our original quantity, and here's a new quantity. Here's our original rectangle, and here's our new rectangle. The original rectangle was 1000 by 100. I don't know why I squeezed everything so crowded. I should have had a forethought, but I didn't. And here is our 1300 times 70. How do these two quantities compare? You're comparing these two quantities. You're comparing this quantity versus this quantity. Think of this as a column A, and think of this as a column B. And your job is to tell them what happened here. Okay, listen to me. Your job is to tell them column B is how much different than column A. The new quantity is how much different than the original one. That's what appears in the GRE. They call it quantitative comparison because we're comparing two quantities. Let's divide both of these columns by 100. If you divide this column by 100, and if you divide this column by 100, which is perfectly legal to do, I'm going to put that 70 here so that I don't have to deal with it here. It's too crowded. And let's make this thing, there we go. If you divide both sides by 100, this 100 drops out, and this 100 will take out these two zeros. Now what I'm going to do now at this stage is to take away the baby step. I'm not going to show you the baby step because you're grown up. I'm not going to treat you like a baby. That's it. We have divided both columns by 100. Let's go one more round. Divide both sides by 10. If you divide this side by 10, and if you divide this side by 10, this 10 will drop out and this 0 will go away. Similarly, this 10 will go away and this 0 will go away. You with me so far? Again, I'm going to take away the baby step. You just have to realize that that's what I just did. We divided both columns by 10. What are we left with? In this column we are left with 100, and in this column we are left with 13. You see, remember these two zeros are gone. 13 times 7. Let's do it out, shall we? 3 7s are 21, 1, carry 2, so 7 1s are 7, plus 2 is 9. We have gone from 100 to a 91. 100 to 91 is a drop of 9%. Voila, we are done. Apparently the area of the rectangle dropped by 9% as the result of our lengthening the length, stretching the length or increasing the length by 30% and shortening the width by 30% as well. The width was 100, now it is 70. So we have shortened the width by 30% and we have increased the length by 30%. I find it funny to say lengthening the length. So let's substitute the word lengthening by increasing. It sounds better. That's it, we're done. I'm not going to do the last problem on the page. Last problem that you see there is a nasty one. I'm going to do it separately. Okay? I'll see you tomorrow on day number 15. I hope you're getting something out of it. Stay with me. We're going to do a few problems, as I said before, every day. You keep track of where you are in the days, which is why I take them by the days in addition to page numbers and so forth, because that way you can keep track of your progress. You can keep track of your work. Get a separate notebook, call it the SAT notebook, SAT math notebook, and do the problems with me. Do the problems ahead of time, and then watch the videos, and you'll see you'll get a hell of a lot more out of it. And if you do every single problem with me, there are 10 exams in this book. If you do every single problem with me, which is what my intention is, you will be in a far better shape for the math portion of the SAT than you will ever be. You understand? I'll see you tomorrow. Bye now.